Hi guys, it's Miss England reporting from Normal, Illinois. It is Wednesday and I am making this video for your assignment for Thursday. It's gorgeous out today. I went for a run with the double stroller with both the babies in them. That was tough. So, hence my appearance. Okay. Anyways, you guys don't care. You don't judge me. I'm looking at yourself right now. Did you shower today? Have you showered yet? Have you? Are you sitting there in your pajamas still? Some of you are. So don't judge. No judgment zone. Okay, so for today's activity, I am hoping that you can work in partners, although you don't have to. Ideal world, you would do a Google Meet with your partner for the lab. So I think you know how to do Google Meet. I can't do it, the whole thing with Google Meet because last time I tried it, it crashed my Screencastify. But I will kind of walk you through how to do it. So you just go to anything Google, click over here on the 9 Google Apps thing, and then go click on Google Meet. That will pull up a screen. You click Join Meeting, and then it will give you a code for you to invite your friend to, and you guys will be able to see each other and do the lab together, which is the goal. Okay, so my goal for you today is to not make a 30-minute video, but make it a little bit shorter and give you more time to work on your assignment. So what I want to do today is review what you figured out yesterday about the types of natural selection. And then the new content is you guys are going to do a lab simulation in pairs if you want. It can be done individually to figure out how a new species arise. So the assignment will be the lab on the Google Classroom. Sorry for the sawing in the background. My husband is working on a closet redo for me. So, okay, what you learned yesterday, there are 3 types of natural selection. Okay, and each type, you're looking at how the population shifted. And I almost forgot, I graphed your guys' reaction times in a histogram, and look at what we got. We got a nice little bell curve where we have most of you following in this, like, let's see, almost 24 of you fall into this 0.21 to 0.32 reaction time. A bunch here, very few outliers. So when we look at human reaction time, we also see that bell curve. If we looked at human height, we'd also see that bell curve. So that worked out nicely. Okay, so that bell curve, what we look at when we look at the types of natural selection is how the population has shifted. Okay, pretty simple. If it's directional selection, it shifts towards one of the extreme. We looked at this with the rock pocket mice where it went from being light to dark at location B. For disruptive, 2 different phenotypes are selected for. So the white and the dark would have an advantage. The intermediate has the disadvantage. And in stabilizing, the 2 extremes are both selected against, and the intermediate has the highest fitness. Okay, so when we look at a population changing like in color, that's something called microevolution. Small changes in populations resulting in basically changes in the phenotype. It's still a mouse, it just looks different. That's pretty easy to wrap our heads around. Next, what we're going to start to look at is macroevolution, and that is at the species level. So macroevolution has 1 species that results in 2 species. This is a process called speciation. Okay, now many of you on your initial models, I don't have the initial models, I passed them back to you guys. When you were asked how new species arise, I got some real funny stuff. I had a lot of people put that a new species arise because a dog breeds with a cat, and then you now have a new species called a cat dog. So that's why I put the meme of the duck face. That is not right. That is not how a new species arises, but it was funny. Okay, so if you look at the 3 types of natural selection, which one do you think is going to arise in 2 different species? Well, if you're thinking disruptive selection, where you have 2 different traits being selected for, you're on the right track. Okay, so the question that is at the heart of the simulation that you're going to do today is how could one population that has variation, heritable variation, give rise to two different species. Okay, that's the goal of what you're going to figure out today. So the lab on the classroom is pretty simple. You're going to, you can maybe do the pre-lab separately and then check your answers. That would be my guidance. So here's our lab question. How does a population consisting of individuals of the same species become a new species? Okay, and here's some background reading. It's going to introduce microevolution, macroevolution, and gene flow, and then you can do the pre-lab questions. Where you want to start working with your partner is where it says simulating speciation activity begins here. You're going to look at a hypothetical frog situation, and you're going to click on this little Google drawing that I did for you. Look at the frog I drew. I do have some artistic talent. So I'm assuming you know how to do Google Drawings. I'll demonstrate really quick. So you double click on it, and if you want to change the color of him, like let's say I want to change the color of his body, I click on what I want to change the color of, and then I can make it be like red, for example. Oops, nope, Control Z. I fill it with red. So I can make a red-bellied frog, okay? So let me undo that, but that's how you do that. And then you click Save and Close. The only thing that I noticed is going to be a little bit annoying is you're going to have to click Save and Close on the drawing, like every time you're done fixing it. So in a nutshell, you're looking at how this species could possibly divide into two different species. The instructions are down here. You can use this online dice roller, but it's really simple. You're going to roll the online dice or get real dice and follow the instructions. And then when you're done with the simulation, you'll each have your own lab where you've colored in each other's frogs. And then you're going to figure out down here, is it a new species or isn't it? So once you're done with the simulation, which ends with round 3, this is the chart for the mutations that you will need. Then you're going to come down here and answer the after simulation questions. Okay. And I would work on that with my partner as well. Okay. So complete the lab. It's really self-explanatory. I had my students do it last year when I was gone at a conference, and the students were able to figure it out easily, and the sub didn't walk them through it. So the instructions are pretty self-explanatory. So hopefully by the end of this, you figure out how one species can divide into two. All right, that's me signing off for now. Text me or email me if you have any questions. Bye. Oh, one last thing. If you're doing it individually, you will do both person 1 and persons 2. You're just going to represent that same person with one person. Okay, so you can do this by yourself, but you do need to fill in both sides of the mountain. So you'll have to do person 1 side and persons 2 side. Okay, and you'll figure that out as you read it.